Hi folks, and welcome back to Physics with Captain Rod. Making this video here to be another kind of introductory example of how to deal with frictional forces in various problems in mechanics. So this problem we're looking at here, for those of you who've watched lots of my videos or you've been in my classes, you know who this fellow is here. That's Timmy. And I like to use Timmy in lots of my discussions here. So Timmy has connected this rope to this rock, this 20 kilogram rock, and he's going to attempt to drag that rock across the surface here. Timmy is able to pull on that rope with a maximum tension of 100 newtons. He's going to do so making an angle of 20 degrees with the horizontal. And what we're going to do is, given these frictional coefficients between the rock and the ground, and I just made those up off the drop of a hat basically, we're going to try to decide whether that rock will accelerate, yes or no. And that's it. We're not going to go any further than that for this particular problem. Just yes or no, can Timmy budge that rock basically. So always start these with a good free body diagram. Now, it's okay to draw a free body right in your original picture, but I really prefer, I always recommend people do not do that. So what I'm going to do instead here, draw a new picture of the rock, and draw my free body here now. So force vectors acting on the rock. Timmy is pulling up at a 20-degree angle with a tension, I'm going to assume at maximum 100 newtons. 20 degrees with the horizontal. The rock is supported at the ground vertically with some sort of normal force, or what we would call a normal force. That's basically the ground supporting the rock. The rock's got a pretty reasonable weight, an mg down. And again, remember, these force vectors have what's called a line of action. That mg can basically go anywhere along this line. And they go through what's called the center of gravity of the rock. For now, in this particular context here, just basically through the center of the rock is good enough for that discussion. And the normal force as well can go all along this line, really. You can draw it anywhere. I'm going to go ahead and make it right there. And the last one there is a frictional force. We would expect a frictional force since we're given frictional coefficients here. And friction always opposes motion, so in this context, in this problem, the frictional force will go to the left. Now, that free body's done, basically complete, and now we're going to start analyzing it. In order to know whether or not that rock's going to accelerate, what we need to know is this. Whether the horizontal component of the tension, if I draw that in red right here, boom, and I'll go ahead and draw the vertical component here. The big thing is whether or not this force vector is bigger than this one. If the horizontal component of that tension is larger than the maximum possible frictional force, then the rock will accelerate. Now, the horizontal component, sorry about my photo, could have been a little better here. This is a 20-degree angle, so this thing has a magnitude of 100 newtons times the cosine of 20 degrees. I guess I'll go ahead and calculate a value here for that. Hopefully this calculator is in degree mode. I suspect it is. That's 93.9 newtons. I'm just going to call that 94 newtons. So now the question is the maximum possible frictional force bigger or smaller than the 94 newtons? Now, that's where the frictional coefficients come into play. So the maximum possible frictional force is equal to your coefficient of static friction times your normal force. Usually when you're dealing with frictional forces, you're going to need the normal. And the way you get those is by writing a force equation in the direction of the normal. So I'm going to go ahead and start by writing this out. Sum of all forces in the, I guess for now I'll call that the y direction. Right? I'm talking about this direction right here. If we sum those up, we're going to get 0. Now the way I know that for sure, the rock weighs almost 200 newtons. I'm getting that from mg. There's no possible way a 100 newton force is going to accelerate that rock up. So I know this thing's not going to accelerate up. Go ahead and write up positive for this equation. And again, the equation comes from the free body. If I start looking at things in the vertical direction, that's this, this, and this. I'll go ahead and write them in that order. So normal minus mg plus, I'll go ahead and put t sine 20 for now. That's this guy right here, opposite the 20-degree angle. This sum is equal to 0. And now what we can do is we can solve this for the normal by adding the mg and subtracting the t sine 20. I'm going to go ahead and just do that and not quite write it all out. And I get 1925 newtons. Okay, so now our maximum possible frictional force. And now we're going to look to here. Our static coefficient of friction, 0.7 times our normal of 1925 newtons. Looks like it's not even close, but $1,347.5 newtons. I'm just going to call it 1,340. Let's just call it 1,350 actually. That's good enough. So 1,350 newtons is our maximum possible frictional force. There is only, young Timmy can only apply 94 newtons horizontally under these conditions. That rock is not going anywhere. Accelerating, yes or no? Now, keep in mind one thing everybody should know, what is the actual frictional force equal to in this problem? It's not this. This is the maximum possible frictional force. Actual frictional force we can get by writing the following force equation. Sum of all forces in the x direction is equal to 0. We know the rock's not accelerating now. It doesn't matter if we go left or right positive. I'll go ahead and do right positive. And we already discussed we got 94 newtons to the right, frictional force to the left. If you solve that for the frictional force, actual frictional force acting on the rock is 94 newtons. So again, this is just meant to be kind of an introductory video on dealing with frictional forces. Usually you're going to need the normal force. So we usually start by drawing a free body. If you think that these are going to come into play, then you're going to need the normal forces. After you draw the free body, you write a force equation in whatever the direction of the normal is. In a lot of those problems, you'll usually end up with 0 accelerations, but not necessarily. That isn't always the case. Don't think for a minute that it has to be. But usually you probably will, and you get the normal from that equation, and then you can move on to the rest of the problem. So, hope that this video helps give you some understanding of how to deal with friction and frictional coefficients. Have a great day.